Hello, you're watching the development vlog for Shokin, a restaurant waitlist management tool soon to be made available on Android and iOS. This is Bill from Shokin, and this is week 58 of development. You'd have to excuse my composure a little bit this time. Every time when I swallow, there's a small nuclear explosion happening in my throat. The current status of the app is that the Android and iOS alpha test version of the app is ready and available for testing on Google Play Store and iOS App Store. And every week, I push more and more bug fixes and updates to the app. So in other words, they're not sitting in stone, they're not frozen in time. They keep being improved on a weekly basis. In addition to that, the goal for last week was to set up and complete the product website for the app. In other words, the website people can go to when they want to look at this app. I'm almost done with that, but I got distracted by something else. I committed the cardinal sin, which is doing things that I wanted to do instead of the things that I needed to do. So like when I was a kid, instead of doing homework, I liked to play video games. And now instead of finishing the product website, I went ahead and attempted a revamp of my CI/CD pipeline to incorporate a more automated version of my development workflow. And I'll expand on that a bit later. Now, obviously, that's not something that's strictly speaking necessary at the moment for me. It's sort of the case of trying to sharpen your tools so that perhaps in the future your efficiency would be better. But of course, there's no end to that. And that's the problem I ran into. I'll talk about what I learned about that in just a second. So, because I didn't finish the product website this week, that's the goal for next week. Let's see if that happens. Let's see if that happens. And I hope it does. In any case, so to expand on what exactly happened last week, I have to discuss a little bit about the current setup that I have with my development workflow. I have a local AI-assisted development workflow in IntelliJ. So the IDE I use is IntelliJ. And then within that IDE, within the terminal, I use Codex CLI specifically. It's an AI coding assistant that's made by OpenAI, I believe. And then currently I use the GPT 5.2. 5.3 just came out. So the workflow has been fairly consistent in that, I converse with the agent within my local CLI, and then because it's an AI thing, it goes off. I dispatch a job, it would go off to do it, investigation, implementation proposal, and the actual implementation itself. But of course, those things take time. And when I ask it to do certain things, I'm asking, especially during implementation, it would actually alter my machine state. In other words, it would start editing the files. It would start, running tests on using programs that only have one instance on the computer, like Supabase, for instance. If you invoke Supabase command to test your database locally, you can only do that one at a time. You can't just spawn another Supabase command because there's one global instance of it. And this greatly limits my throughput because when the AI task is underway, I dare not interrupt it, because if I did, or if I tried to do something on the side, it would actually alter its state and then confuse it. And then it might do things that would alter my state and confuse me. So, of course, there's ways to overcome that. You can spin up multiple virtual machines, and that's just too much effort. And from my experience, I can work on two things at a time. And anything more than that, I myself would start losing context and failing to context to switch appropriately in between tasks. So that's the impetus of the problem. Like, that's what got me to be very interested in what I did last week in the first place. What happened last week was that, on one of those late nights, I was browsing the internet and discovered this new feature. It's not really new anymore. It's been going on for a little while. Codex Cloud. Never heard of it. And to be honest, it's partly it's partly my fault. It's also partly just the marketing people at Codex and OpenAI and all of those companies. Like, people, name things differently. Otherwise, it's just going to be very difficult for our tiny little brains to figure out what is a new product and what is not. If I told you Codex Cloud, would you think that it's a different product than Codex CLI? I mean, now you do, because I told you that, but if you didn't, then you wouldn't know. So for the longest time, I thought Codex Cloud was just, Codex CLI in the cloud. I didn't really think too much of it. But I dug deeper into it this time. Codex Cloud is, yes, it is Codex CLI in the cloud, but it works best in conjunction with your GitHub instance. So what you do is you connect your Codex instance to your GitHub instance. And then Codex OpenAI servers can then read your repo from GitHub. And then whenever some events take place in your GitHub repo, Codex servers can then respond with some actions that involve AI. One of the biggest things that they've been trying to push is code reviews. So let's say that you have a PR, a pull request open on your GitHub repo. If you have those things set up correctly and automatically, what would happen is after a PR gets opened and put into an actual PR mode as opposed to the draft mode, Codex Cloud would see it and then trigger a code review. And then in my repo, it takes about 15 to 20 minutes for a code review of a moderately sized diff. And then it would post either some review comments suggesting you to change certain things, or it would react with thumbs up saying that it didn't find anything wrong, so go ahead with the merge. So that's quite convenient. And not only that, if you think about it, if Codex Cloud is doing the work in the cloud with your GitHub, you don't have to actually worry about the context on your computer, on your local machine as you're developing, right? So you push a branch up, you open the PR, and then Codex Cloud would just review it and then give you its reaction. So that's all well and good. And then gears started turning in my head. So you tell me you have Codex Cloud. What if I try to automate the code research, the issue research, the implementation proposal, the review of the implementation, and the actual implementation, and the code review, all of it automated in Codex Cloud? Wouldn't that be great? Now, obviously, before the PR merges, I like to intervene and then go through the entire thing and then apply my expertise to see whether or not I want something changed. But between the issue description and scoping and all of that, and the eventual product of a PR ready to merge, what if I can just automate that instead of me going back and forth with the Codex CLI on my local development environment? So gears started turning. I was like, let's take a look. I immediately ran into a problem. Codex CLI's current connection with GitHub does not allow for any automation beyond what it can do or sanctioned by Codex. That's number one. Number two, it cannot really allow for much customization. So what do I mean by it can't do much beyond what Codex sanctions? Currently, Codex sanctions two ways of interacting with Codex Cloud from your repo. One is automated code review, which I just described. You have a PR ready, Codex Cloud will find it and PR review it. But you can also interact with it by typing in @codex in a comment and then giving it an instruction on, take a look at this, take a look at that, or implement this, fix that. This part has to be done manually by a developer. You can't have your GitHub Actions comment @codex. It just won't work. It requires a human being to be there putting in the @codex comment for it to do. In other words, every time when you want Codex Cloud to do something, you'd have to get a human involved to type in @codex and then give an instruction for that. Now you might say, hey, so instead of using GitHub tokens, you could use personal access token (PAT) from GitHub. It would post a comment as if a human posted the comment. You're right. This bypasses the original design limitations, but you'd soon run into another issue, which I'll describe later, which I believe is also part of the reason why OpenAI didn't officially support the full end-to-end automation that I'm trying to do. So that's number one. It requires a human to comment before Codex Cloud would do anything other than doing automatic PR reviews. The second problem is the because it's all locked down. So how would I describe this? When you're doing Codex CLI locally, you have a lot of leeway in terms of you can pick your model, you can pick the reasoning effort, you can give your special instructions for it. You have an entire agents.md file that contains, at this point, probably gold in terms of making an agent effective. I mean, a large part of why I see a lot of people on the internet complaining about AI slop and AI just not working for them is a combination of model selection, reasoning effort selection, as well as the agents file, the agents instructions. You have none of those controls with Codex Cloud. As far as we understand, they can use any model if they want. They could use GPT-2 or, God forbid, 1, right? You don't have to control. You also don't have control over reasoning effort. So if you have a bigger problem, you wanted to spend more tokens thinking about it, you can't control for that. Not only that, it does give you a section for sort of customized instructions that you can put in. Number one, you can't version control it. You interact with that through a web portal. And number two, from my experiment, their current implementation doesn't seem to really respect it. So you can go into the log and see all the processes that it's gone through when you're using Codex Cloud. And sometimes your instructions are just not injected. Maybe it is, and maybe the log just doesn't show it. But even if it is, from my personal anecdotal evidence, it's not nearly as effective as when you're using those instructions on your local Codex CLI instance. So these are the two big issues that prevented the automation. And then I thought to myself, hey, to overcome the first problem that I described, which was, you have to get a human to put in the add codex. I was like, oh, well, let me just use a personal access token. So I did do that. Number one, don't do that. Very dangerous. Okay, this is not a security discussion, by the way. This is literally at the pre-launch, before any vulnerable customer data start showing up on the server. You can do this to save time. In production, never do this. Never do what I did last week. Because again, if you think about it, an agent is literally an autonomous entity, human being, living inside your repo. It can do anything. It can delete it. It can send it to somebody you don't like. Yeah, don't do any of this. But as a thought experiment, it's interesting, to have done experiment. Anyway, so I was like, let me use a personal access token. So I did. And voila, it actually solved the first problem. If you use a PAT in your GitHub workflow to trigger @codex, it would actually trigger correctly. Now, obviously, big red flag using PAT in your GitHub workflow because it acts as a human, right? And if you don't scope it right, and even if it did, I mean, there's a lot of security risks there. That aside, I was like, oh my God, there is a whole world in front of me. I can use that to trigger a codex research, again, implementation plan, actual implementation and stuff, and all of that. It was great. And I immediately ran into the next problem, which is the virtual environment that Codex Cloud provisions for their agents must be running on potatoes. Very slow. My guess would be something like, I don't know, like 1 core or 2 core with half a gig of memory. It's something ridiculously small. What happened was the agent was actually able to perform investigations and add code and stuff. However, because we're talking about an Android Kotlin multi-platform project here, we got dependencies up the wazoo. You have to make sure that they all compile and all the tests pass. And my test suite, as well as in general, just Kotlin multi-platform compilation using Java, very, very heavy. From the log, I could tell that like one compilation plus full suite run, a full test suite run, took the agent environment over an hour. And then what had to happen was, I mean, no agent really gets it right the first time, especially considering that they don't have context. By the way, Codex Cloud also doesn't allow for a MCP server, so you can't use context 7 to double check on your syntax. That's another problem, but I neglected to mention that's another limitation. So 1 hour for an entire test suite run plus build verification, and then the agent would then have to think about, oh, how do I correct this, and then push it again, trigger the tests again. That's another hour wasted. And the funny thing is, Codex Cloud, kudos to them. That's what they actually should do, is they kill your instance after, I believe, an hour or an hour and a half. The agent would just be like, man, it's taking too long. I don't want to do this anymore. Let's kill it. So you can actually never, Codex Cloud can never actually get this done because it just doesn't have enough time to do verification for you. Now you might say, as I did to myself, why don't you move the verification outside of the agent workflow, agent environment, put it into GitHub workflow, since you already have PR gates and branch checks on in your GitHub anyways. I'm glad you asked. So I did do that. And obviously, depending on the runner size or the runner provision that you have, the tests on GitHub Actions would run a lot faster. That's for sure. I mean, each test is about, for me, is like 5 to 10 minutes for a full suite run. A lot faster than obviously an hour. The problem with that is it dramatically increases the time that would take for each iteration. So imagine the Codex Cloud be like, oh, I'm done with editing. Let me push branch up and then monitor the situation. So it pushes the branch up, and the branch triggers the test workflow. Inevitably, the test workflow will come back with errors. And then my GitHub action would then invoke a new cloud agent to start investigating the errors and then hopefully fix it and push up a new one. But every time when the agent initializes, it creates an entire new environment. That takes time. And not only that, it loses all the context of the previous agent. So you lose the benefit of maintaining context with a single agent as you're diagnosing it, because then it wouldn't take more than 2 to 3 iterations before the new agent starts repeating the mistakes that caused the first agent to fail the tests in the first place. I literally had one of those experiments set up and I went to bed. And the next day I woke up, it was like after 5 attempts, it just died. And because I time it out after 5 attempts. And then I also woke up to my entire weekly quota from Codex being drained just from that, because the agent just kept looping because it just didn't have the context. Now, of course, you can say, sure, maybe have the agent output the context and comment, and then you just get into this world where, like, how much time are you going to spend to try to improve this, right? Try to make this work, try to shoehorn this solution to make it work for you, maybe for a little bit of time before Codex changes its mind about what it's offering on Codex CLI. So I gave that up. But before I gave up the entire idea of automating my workflow using AI, in the GitHub workflow environment, I gave it one last try using not Codex Cloud, but Codex CLI within GitHub workflow. So just to be clear, in this approach I tried, I didn't bother with Codex Cloud at all. Like, Codex Cloud might as well just not be connected to my GitHub Actions. So what I did was I already use GitHub's self-hosted runners. I'm not about paying money to get GitHub to run my GitHub workflows, because my workflows are very, very heavy, and particularly given the fact that I have to use a macOS runner. I mean, GitHub charges an arm and a leg for that. So I'm not doing, I think 6 cents per minute or something like that. I mean, I can't do it. Anyway, so what I did was I just installed Codex CLI on my GitHub runners. And then in my GitHub workflow, I would ask the different steps of my workflow to invoke Codex CLI using essentially detached mode. So typically in Codex CLI, you start Codex and then there's a prompt, right? You interact with it. It responds, you respond, it responds, you respond. It's like that. But there is a way to, of course, have it execute something. You give it a command, give it a prompt, and give it, parameters that you want. You can specify anything. This is another benefit of doing it this way. You can specify your model, you can specify your reasoning effort, and all of that. And then you can just send it off. It would run as a detached job, right? In other words, you're not interacting with it. And then it would come back with actions, and it would, do things in the background. So this is perfect in GitHub Actions. So I set that up. And I was like, oh, okay, so I can do a slash commands. I thought it was so neat and cool, right? In the GitHub Actions, in the GitHub issues, I was slash investigate, and it would kick off a GitHub action, and it would wake up my runner, and then have code execute investigate, and then come back with the investigation report in the comment. And then after that, the GitHub Actions would then automatically trigger a proposed implementation, and then it would send the job off to a codex on my GitHub runner and do all of that. It all sounded good in theory until the next day after I sent one job off and just tried to see what it would do. Okay, it did the same thing, exhausted my credits. That's number one. Number two, it got nowhere near where I wanted to go. One of the biggest reasons why AI can work in programming is that you have to constantly steer it. We're nowhere near sort of fully automated AI agent yet, because if you're not there to steer it, to keep things in context for it, and it also doing it by itself, through 5 or 6 chained AI actions, you're going to start playing the game of telephone. You might have the original intent at the beginning, and then at the end, it's just going to be very different. Again, sure, you can argue that you can detail all those things, all of those limitations, all of those requirements in your issues in the first place to prevent drift in the chain of implementation. But let me be clear, you're not going to be able to do that. If you've ever done anything that's non-trivial, every implementation, there will be exceptions, there will be things that you didn't know existed before, there will be considerations that you have to give to it that you wasn't even in the realm of observability when you were tackling the problem in the first place. So in other words, when you're interacting with the AI agent locally, you have the opportunity to converse with the AI agent. You have the opportunity to course correct as early as possible, and you have the capability of making decisions on things you didn't foresee before. When you're trying to automate the whole thing in the cloud, you don't have any of these opportunities, right? It takes the best assumptions that it can get, and then again, after 5 or 6 repeats, it's just going to go out of whack. So that was a dramatic fail as well. And also in addition to that, I didn't fully investigate the reason for this. Using this automated chain to fix build errors as well as test failures, woefully inefficient. I have some theories about why this is the case in the cloud versus locally, but in any case, it's just not a pleasant experience. So in other words, last week was a whole lot of nothing in terms of investigating the possibility of automating my AI-assisted workflow in GitHub workflow, and failing, but with important lessons learned. So at the end of last week, what changed was I returned mostly to my original workflow, which is using local Codex CLI within IntelliJ. But I did retain the code review capabilities of Codex Cloud because, number one, it is helpful. It did catch things that the local agent sometimes would fail to catch because it's got a completely brand new context, right? And number two, it's on a different quota than the quota that you get allotted for when using Codex Cloud or Codex CLI. So it's really not costing me anything extra. So I'm keeping that in. But in terms of the wet dream of just, from A to Z, completely, fully automated, maybe one day. maybe one day. It's got potential though. Like just the fact that I can chain them together and have them just have the domino fall one after another instead of just one falling down with a loud clank and nothing happens afterwards. Like that's already a huge improvement that I wouldn't have imagined would have been possible just a couple of years ago. So look forward to the development in this area. And this is my long soliloquy when, again, nuclear explosions happening in my throat. But I thought it was interesting to explore. I definitely got distracted by that. I thought it was like doing something really neat, but I guess I was, but I just didn't manage to actually accomplish it. That said, regular business resumes next week. I'm gonna finish that website, I promise you, and I promise myself. And I'm gonna put in the screenshots and the spiel. And then if I have time, I'll start working on the one-pager, the physical one-pager that I can have with me when I go out to restaurants and send the one-pagers out. That's it for this week. I'll see you next week.